Okay, so now we're going to be using a sum formula for sine. So again, it says find the exact value. So we want to keep that in mind. And this is like sine alpha plus beta. Okay, now alpha is going to be that inverse cosine of 1/2, and beta is going to be inverse sine of 3/5. Okay, now I wouldn't do it the way they show in the book, but I'm going to. I'm going to do it that way because I want you to see how that works. And then I'll show you the way I would do it on another problem later. Okay. So I have to think about this inverse cosine being 1/2. Well, remember that if you had sine squared theta plus cosine squared theta, this is just the Pythagorean identity. It's equal to 1, right? So sine squared theta is equal to 1 minus cosine squared theta. Well, that was the alternate form. But then you could take the square root. Sine theta equals plus or minus the square root of 1 minus cosine squared theta. That's true. Okay, so all of that is true. Now, what we have here is we are knowing that there's some angle out there, call it alpha, such that the cosine of alpha, so I'm going to call that alpha, is equal to 1/2. So if I want to find the sine of alpha, it's going to equal, now is it going to be positive or negative? Remember, these are inverse functions, so they're limited. For cosine, it's either first or second quadrant. It's got to be first quadrant because my cosine's positive. So my sine's going to be positive as well. Square root 1 minus, and then I'm going to use the cosine that I know, 1/2 squared. Okay, so I do some work here. 1 minus 1/4. So what do I get? Square root of 3 over 4, which is going to simplify to be the square root of 3 over 2. Okay? So now I know the sine of alpha. Okay? And I might need that. Do I already know the cosine of alpha? I do, right here. Okay, so I'm going to start writing out this formula for us. So we know that the sine alpha plus beta is equal to sine alpha cosine beta, that's our new formula, minus cosine alpha sine beta. And now we can start filling things in. So I'm replacing this with alpha. Okay, I'm doing this in orange. This is my alpha. Okay, so look where there's alpha, right here and right here. And do I know the sine of alpha? I do. It's the square root of 3 over 2 because we just figured that out. And do I know the cosine of alpha? I do. It's 1/2. Okay, so now I need to work with beta, right? Okay, so I'm going to make this my beta. So I'll do it in green. Hopefully the colors help. And so we're going to use a similar idea. So this time we know inverse sine is 3/5. So if I want to find, well, I'll write this. So sine of beta is equal to 3/5, right? We're not actually going to figure out what that angle is, beta. We're not going to figure out what alpha is either. We just need to know the sine and cosine of them. Okay, so if sine of beta is 3/5, I could go back to my Pythagorean theorem that was up there, and instead of solving for sine, let me solve for cosine. So I'm going to say cosine theta is equal to, and I used a theta on purpose, cosine theta is equal to plus or minus the square root of 1 minus sine squared theta. Okay, so you could go back and run those steps just like we did right here where we were getting what sine theta equaled. Okay, but now we're going to do this for beta, our beta in our problem here. Oops. Okay, so I've got cosine beta is going to equal, now again it was an inverse sine. Where was that? Well, it said inverse sine was of 3/5, right? Okay, so inverse sine is restricted to the fourth quadrant, and the first quadrant. So cosine is positive in both of those, so I'll use the positive case. 1 minus, now what was the sine of our beta? Sine beta was 3/5. But we have to square it. Okay, so then we work a little algebra here. Cosine beta is going to equal 1 minus 9/25. And so you're going to get like 16/25, which is going to be equal to, you have to do the whole common denominator thing. It's just some fraction work there. Anyway, we're going to get 4/5. Now remember, that's the cosine of beta. Okay, so now I've got the sine of beta right there, and the cosine of beta, well, it's over here, but 4/5. Okay, so now we can plug those in. So cosine of beta, that's what we just figured out, was 4/5. And then sine of beta, that was 3/5. The other way to do all this work that I'm doing over on the right is with triangles, and that's how I usually do it. But I'll show you the triangles and how to use those in another problem. Okay, now this is a good way. So what do we get when we start simplifying? Well, we have 4 square root 3/10 minus 3/10. So we're just going to write that 4 square root 3 minus 3/10, and it doesn't simplify, and we'll be happy. Okay, there you go. I was looking back at my work and I see an error, but rather than redo this, I'm going to fix my error. So it should have been a plus here. So I just wasn't remembering the formula the way I was supposed to. So there, now that looks better. It's always good to check your work, especially on these long problems, but I just wrote the formula down wrong, which was silly of me after I explained how to remember, oh, when it's sine, it's plus on the left and plus on the right, and then I spaced it. Okay, so it happens. Anyway, that looks better now. That would be the correct answer. Okay.